Solving a system with graphing, the only way we get a perfect solution is if when we have our, our graph paper, the lines intersect at a point, like a perfect point. If they intersect somewhere, in the middle, I don't know what that value actually is because it's not lining up properly. So graphing doesn't always work. It doesn't always give us an exact solution. Not to mention the fact that most of you probably don't care to graph. So we have other methods, and the first one is substitution. Okay, so first I'm going to show you the steps, or write down the steps. I'll give you time to write those down, and then I'll show you how they work. Okay, so I'm going to pause this. With the substitution method, the first thing you want to do is make sure at least one of your equations is in the form of x equals and then everything else, or y equals and then everything else. So you want the x or y by itself on one side of the equal. And it doesn't matter if it's x or y, it can be either one. After you have that, so if it's not already like that, you have to create that. After you have that, you take what's in the box and you substitute it into the other equation, which I'll show you what that looks like in a minute. So, for example, if I have x equals the box, I take what's inside the box and replace x with that. If it's y equals, I take whatever's inside the box and replace y. And then I solve it. And that'll give me the answer for the other variable. So if I had x equals, I'll find the answer for y here. If I had y equals, I'll find the answer for x here. And then I take whatever that answer is, and I go back to whichever one of these I had, take this answer, plug it in, and then find the second answer. Okay? So, what that looks like, I have y equals, here's my box of everything else. I take this and I put it where the y is. Here. So instead of being 3x plus y equals negative 9, I have 3x plus so here was that box. I took that and put it here for the y because they're equal to each other, so I can take one out and put the other one in. It's sort of like when you make change or give change. You substitute 4 quarters for $1. They look different, but they're the same thing. Does that make sense? Okay. So 2x plus 1 and y are the same thing because they're equal. So I can switch them out. Now that I've done that, I've taken the y out and put the 2x plus 1 in. I only have x's left, so I can find out what x equals. So 3x plus 2x is 5x. I subtract 1 from both sides. I get 5x equals negative 10. Divide both sides by 5. And that tells me that x equals negative 2. That's my first answer. But I need both. I need to know what x equals and I need to know what y equals because I need that ordered pair. So, just for this was step 1, this was step 2, here's step 3. I take this value for x. I had y equals 2x plus 1. I take that negative 2 because that's what x equals, and I replace the x with the negative 2. 2 times negative 2 is negative 4 plus 1. So that gives me y equals negative 3. Here's my second answer. So my final answer is the ordered pair 2, negative 2, negative 3. This is my final answer. That's the solution to the system. I found the x and I found the y. Already y equals 4x minus 6. So I take that 4x minus 6 and I'm going to plug it in for this y right here. So this y is going to come out and 4x minus 6 is going to go in. So I'm just going to rewrite it so I have a little bit more space to take this and put it in here. So it's going to become 5x plus 3 times 4x minus 6. Okay, so this box replaces the y. Okay, from there I need to distribute that 3. So 5x, 3 times 4 is 12, 3 times negative 6 is negative 18. Then I have to combine my x's. 5x plus 12x is 17x minus 18. Going to add 18 to both sides. 17x equals 17. So I'll divide both sides by 17. And x will equal 1. Once I found x, I take this part, the one I originally plugged in, and my answer from x replaces x. So I get y is equal to 4 times 1 minus 6. So that's 4 minus 6, which is negative 2. So now I have my two answers, and I can write down the system solution as my ordered pair. I'm going to use a different color.
Does it matter which one is first?
Yes. It is always going to be in the form x, comma, y. It goes alphabetical. So if you have other letters that aren't x and y, you can still write it as an ordered pair as long as you put it alphabetical. So A would come before B, P before Q, or whatever. They just go alphabetically. Here, same situation. I already have one in the form of y equals. So I'm going to take this and plug it in for that y. Okay, so I took the 3x plus 10, took the y out, put the 3x plus 10 in. Distribute the 5. So 2x plus 15x plus 50 equals negative 1. Add those together. 17x plus 50 equals negative 1. Subtract 50 from both sides. 17x equals negative 51. Divide both sides by 17. You guys have your 17s memorized, right? No?
Like the multiplication table?
Yeah. No?
Not 17.
No? Oh. Okay, I think it's 3. Hold on a second. Yeah, it's 3. I was kidding. I don't expect you to have your 17s memorized. Okay. So now I have the x, and I'm going to take that y, plug the x in. So 3, whoops, y equals 3 times negative 3 plus 10. So that's negative 9 plus 10. So y equals 1. So my answer is going to be -3, 1. Like the ones we've been doing, it was nice because we already y equals or, you know, whatever. Sometimes they're not in that format. So what you want to do is you want to look for the equation that you can most easily put into the format of x equals or y equals. In this case, it's going to be this one that we are going to adjust. So I'm going to take this equation first, and I'm going to rearrange it. Oops, that's a +6. By subtracting 2y from both sides. And I'm going to get x is equal to, I can either say -2y plus 6, or I can say 6 minus 2y. It's the same thing. It's just like my y's in front. Then, now that I have this in the form of x equals, I'm going to take that box, take the other equation, and replace x with what's inside the box. Okay, so this was step 1, is making sure I had the formula equation in the right format. Step 2 is the plugging things in. So x gets replaced with 2y plus 6. Distribute that 3. I'm going to combine my -6y and my -4y. Subtract 6 from both sides. Oh, no, not 6. Guys, catch me when I do stupid stuff. You get extra credit. There we go. I distribute the 6 to both terms inside the parentheses. See how easy it is to make mistakes? That's why you always check your work. Okay, -10y equals 10. Divide by -10 to get y equals -1. So x equals -2y plus 6 from here. Y is -1. So I plug in the -1. So x will equal 8. Which gives me my solution of 8, -1. So even though we found the y first, because it's y, it gets put into the ordered pair second. Situation where you have no solutions or infinitely many solutions. You remember with the graphing, if you got the same line on top of each other, or 2 parallel lines. Well, with a system like this, that can also happen, but I want to show you what it looks like. So I take my y and I plug it in. So I'm going to have -6x plus 3 times 2x minus 4 is equal to -12. I distribute that 3, and I get -6x plus 6x minus 12 is equal to -12. I combine my x's, and -6 plus 6 is 0. So those go away, and I get -12 equals -12. This is a true statement. When I get a true statement, I have infinite solutions. Now you can either say infinite solutions or you can say all real numbers. Or if you want, you can use the symbol for real numbers, which is a double R. So you can write any of these three things. But if you get a true statement, so a number equals itself, it's all solutions, all real numbers, infinite solutions. Okay. If I plug in this way, so I get 2x minus 2x minus 3 is equal to 8. I distribute that negative, which gives me 2x minus 2x plus 3 equals 8. Combine my like terms, and I get 3 equals 8. This is a false statement. If I get a false statement, there are no solutions. Or you could make that symbol. That symbol symbolizes the null set or the empty set, which means there's nothing in it, which means there's no solutions. So if you get two numbers and they are actually equal, it's all solutions, infinite, all real numbers. If you get a number equals another number and it's not true, then you have no solutions. So I would like you guys to try this one, C, O. Never mind. That's not a very good example. Sorry. We're going to do this one together. So we need to decide if we want to do X's or Y's. X's, okay. So I'm going to use the smaller numbers. So 4x is equal to 3y plus 1. Divide everything by 4. And I'm going to get x is equal to 3/4 y plus 1/4. Okay. And I'm going to plug that in for x. So I'm going to take this and plug it in here. Now, when I multiply a fraction times a whole number, if the denominator will divide, I'm going to do that first. So, no, not equal. Okay. 4 goes into 8 twice. You guys, yes? Okay. So this 4 also would go into 8 twice. So now I have -2 times 3 and -2 times 1. So divide by the denominator first, if it will, and then multiply by the numerator. And if you need extra help with fractions, just let me know. Combine those. 6y minus 6y goes away. So I get -2 equals -2. And what is my answer? All real numbers or infinite. Infinite is spelled different than that. Okay? We have to break this down. So we have a store sold a total of 125 car stereo systems and speakers in 1 week. We have to figure out what letter we want to use for this. I would say stereos and speakers, but those are both S's. And I can't have two S's, that won't help. So what letter would you like to use for stereo systems? Any letter. What letter? Okay, so we'll use S for stereos. Then what letter will we use for speakers? Okay. That's fine. Okay, there's 125 total. So that tells me that S plus B is equal to 125. Okay. The stereo system, that should be a Y, sells for $104.95. So S is $104.95 each. The speakers are $18.95. So B is $18.95 each. And the total sales are $6,926.75. Now, how do we figure out a total sale? Multiply by the number of how many you had, right? Yeah. So that's how much the stereos were all together. This is how much the speakers were all together, and that gave us that. Does that part make sense okay? I want to make this into one letter equals everything else. So do you want to use the S's or the B's? Would you like a hint as to what I would do? I would actually make it B equals, because $18.95 is smaller than $104.95, and I'd rather multiply by the smaller number. That's me personally. But you don't have to. You can do either way and you'll get the same answer, but just I like to multiply by smaller numbers, so I usually pick the one that's going to give me the smaller multiplication or division. Yeah.
That looks like a plus.
Here? This is.
Oh.
Yeah. We're multiplying 104.95 times S plus 18.95 times B. So that gives us, S is the number of stereos and B is the number of speakers. So we take the individual price times the number that we sold, and that gives us the total. Does that help? Okay. So I'm going to make this B equals, and to do that I'm going to subtract S from both sides. So I can do 125 minus S. And I'll take that and I will plug it in for B. And like I said, it doesn't matter if you use B or S on that, because you'll end up with the same answer. It's just a personal preference as to whether you'd like to multiply by what. Okay, so once I'm plugged in, I now have to distribute that $18.95. Okay. Oops, not equal to. Keep doing that. Okay, $18.95 times 125, and then $18.95 times negative S. Okay. I have my two like terms. So I'm going to do 104.95 minus 18.95. And that gives me 86.
by 18. Right?
Yeah, 104.95 minus 18.95.
And that cancels it out.
Yeah, it gives you 86s. The 95s cancel each other out, and 104 minus 18. Let me just double check that, but I think that was right. Yeah, 86. Okay. All right, so now I need to subtract. And I didn't do this in my head. I just want you to know I've already written it down. Divide by 86. Okay, so there were 53 stereos sold. And to find the speakers, I subtract that from 125. So $72 speakers. So we're going to set up this word problem. We have the Yankees and the Reds. So do you guys want to use Y and R? Okay, Yankees, Reds. Okay. As of 2007, the New York Yankees and the Cincinnati Reds together had won a total of 31 World Series games. So 31 games. The Yankees won 5.2 times as many as the Reds. So 5.2 times the Reds. Any question on that part? Okay. This is already in the form of y equals, so I'm going to take this 5.2r and replace y. So I get 5.2r plus r equals 31. .2 plus an invisible 1 gives me 6.2. Divide by 6.2 and you get 5. So the Cincinnati Reds won 5 World Series. And to find the Yankees, I plug in that 5. And so the Cincinnati Reds won 26 games. You could have, if you wanted, plugged it in this way as well. And you'll get the same answer. That's just preference. So you can choose either one. It's fine.